Hello students, welcome back to my channel. I hope you all are fine. Okay, right, sir. And now I'm going to here teach your second year topics. Okay, the second year topic is seventh chapter, moving charges and magnetism. Moving charges and magnetism. Moving charges and magnetism. And now see here, sir. See here, in the chapter, very important two questions are there. One question is state and explain the Biot-Savart law. Okay, state and explain the Biot-Savart law. That is our question. Okay, I'm ready here. State and explain Biot-Savart law. Biot-Savart. Okay, this is the question. Okay, sir. And now see here, for the Biot-Savart law, we are taking see here. I'm writing here answer for that Biot-Savart law because of this is the second year. Once again, I'm telling here. And now see here, sir. Answer is Biot-Savart law. Put the heading Biot-Savart law. Okay. First of all, what is the Biot-Savart law? See here, sir. The magnitude of magnetic field, which is directly proportional to the length of the conductor and angle between that conductor and radius. Okay, and next one, which is directly proportional to the area of that conductor and inversely proportional to the square of the distance between them. Okay, that is the here Biot-Savart law. And now see here, sir, for that Biot-Savart law, we are taking here, let us consider we are taking here one conductor. Okay, let us consider any shape we can take that conductor. Okay, let us consider we are taking here one conductor. The direction of current, it can be shows here along upward direction. Okay, when the current can be passing through along the upward direction. Okay, so it can be produces some field around it. Everyone, you know this one. And now see here, let us consider we are taking one conductor. The direction of current is upward, and that conductor we are taking here one element, small element. Okay, the length of the element is dl. The length of the element is dl. This element also we are taking along the direction of current in the conductor. Okay, and now see here, when the current can be passing through this conductor can be produces here some field around it. Okay, so at this position, let us consider at this position we have to find out the magnetic field at point P. We have to find out the magnetic field dB. Okay, so now I am taking here, this is the, okay, see here, we have to find out the magnetic field at point P, which is at a distance r from the element of that conductor. Okay, this is the R is the separated between, we have to find out the magnetic field at point P from the element dl. And now see here, and it is making us here, what is the current elements are being, for example, see the current element and this conductor, these two are, it is making an angle, that is theta. Okay, that current element, this is the current element. This current element. Okay, what is the current elements are here? That is IDL. IDL is the current element. So this current element with the radius, with the distance, it can be making an angle theta. So now here, see here, it can be produces here magnitude of magnetic field. That magnitude of magnetic field, see, I'm writing here, that magnitude of magnetic field dB is directly proportional to the flow of current along through the conductor, that is I. Then again, the magnitude of magnetic field is directly proportional to the length of the element, that is dl. And again we have to write here, the magnitude of magnetic field is directly proportional to the angle between current element and separation between, distance between them. So that is angle is here, that is sine theta. Then again, the magnitude of magnetic field is inversely proportional to the square of the distance between them. That is inversely proportional to square of the distance between magnitude and magnetic field and this element. Okay, where we have to find the magnetic field, that element. Okay, and now see here. So whenever we have to write the combined equation, we will get here one formula, that is dB is directly proportional to I into dl sine theta by r square. Okay, dB, magnitude of magnetic field, dB is directly proportional to I dl sine theta by r square. Whenever you have to remove here proportionality, you will get one constant. That constant is dB is equals to mu 0 by 4 pi. Okay, mu 0 by 4 pi, that is I dl sine theta by r square. And now here, this is the required formula from this, okay, from this Biot-Savart law. And now if everyone you know what is the mu naught. Mu naught means nothing but here constant value. The constant value is 4 pi into 10 to the power minus 7 Henry per meter. Okay, whenever you have to substitute this value in that formula, you will get here dB is equals to 4 pi into 10 to the power minus 7 by 4 pi into I dl sine theta. I dl sine theta by r square. Okay, and again see 4 pi is cancelled. You will get here dB is equals to 10 to the power minus 7 into I dl sine theta by r square. So this is the required formula. Suppose if you want this equation, you have to write in vector form. So then we have to multiply and divide by here r cap. Then you will get C. Then again dB is equals to 10 to the power minus 7 into I dl in the vector forms are this one. Okay. I dl sine theta into r vector r by r square into vector r. So whenever we are multiplied and divide by vector r, then we will get here again dB is equals to 10 to the power minus 7. We have to write here I is the constant, so we can write outside. So we will get here I. Okay, so remaining is we can write here dl cross r by r square into r cube you will get. So this equation in the form of vector form. Okay, this is the vector form equation. So you have to write from up to here only you will get here total full mass, 4 marks you will get here. This is the most important for 4 mark question. Okay, I think everyone you understand this question. And next one we are having after this. Once again you have to check once again. See, first of all we have to write here explanation part. Let us consider we are taking one conductor. The direction of current is upward. Okay, on that conductor we are taking one small element. That length of the element is dl. It can be also shows here along the direction of current. And now when the current can be passing through this conductor, when the current can be flows through this conductor, it can be produces some magnetic field around it. So we have to find out the magnetic field dB, magnitude of magnetic field dB at point P, which is separated by a distance from the element is small r. And now see here, from this element we are having here one current element. Current element will be produces. That current element is ideal, which is making an angle theta with the direction of field. Okay, and now see here, after that we have to write the magnitude of magnetic field, which is directly proportional, which is where it is inversely proportional. We have to write like this. Okay, and after this we are having here another one most important question, that is Amperes law. Okay, that is Amperes law. That one also most important for 4 mark question. Okay, sir. Now see here, what is the Amperes law? First of all, we have to write here statement. First of all, we have to write here statement. Amperes circuit law. State and explain Amperes law. State and explain Amperes law. Amperes law. This is our questions are here. Another one most important question. And now see here solution for it. First of all, we have to write here statement. What is the statement for it? Means the line integral of the, okay, once again I am telling here, the line integral of the intensity of magnetic field. Okay, the line integral of the intensity of magnetic field around a closed path. See here, line integral, that is B dot ds is equals to, line integral B dot dl is equals to B dot dl is equals to mu naught into I. From that formula only we can write the statement. What is the statement, sir? Means the line integral, the intensity of the magnetic field. Okay, the line integral intensity of the magnetic field around any closed loop or around any closed path is equals to mu naught times of the net current. Mu naught times of the net current enclosed by the area of the path. Okay, this is the statement of Amperes law. Once again I am telling here statement. The intensity of magnetic field, I mean the line integral of intensity of the magnetic field around any closed loop. The line integral of intensity of magnetic field around any closed path is equals to mu naught times of the net current enclosed by the area of the bounded curve. This is called here Amperes law. So we have to prove this one. Proof. How can you prove, sir? Means let us consider we are taking here one conductor. Okay. Let us consider we are taking here one conductor. The direction of conductor is upward direction. Okay. The direction of conductor is upward direction. And now see here, when the current can be passing through this conductor, it can be produces here some field around it. Okay. It can be produces here some field around it. So now see here, we have to find out the magnitude of magnetic field at point P. Okay, at point P, which is separated by a distance from the element, that is R. At this point, we are taking here that element, small element. That small element is dl. So at this position, the length of the element is dl. It can be work upward direction only. Okay, and the magnitude of magnetic field also can be work here only. Both are in the same direction. Both are in the same direction is nothing but both are parallel to each other. Okay, the angle can be made here. Theta value is degrees, 0 degrees. Theta is 0 degrees. Okay, and now see here. So at this point P, we have to write here magnetic field dB. That is B is equals to mu 0 I by, that is mu 0 I by 2 pi r. Mu 0 I by 2 pi r. Okay, sir. I think everyone you understood. Okay. That's what only see where the magnetic field will be produced at the element. That magnetic field is B is equals to mu 0 I by 2 pi r. Okay. So now see here we can write here what is here R means nothing but radius. Okay, and I mean nothing but the current can be flows through the conductor in upward direction. And now for this element we can write here, we know that according to the Biot-Savart law, okay, according to the Biot-Savart law, we are having one formula. What is that, sir? Means I am writing here. What is that, sir? Means line integral, that is B dot dl is equals to, we can write for this element, see, line integral. Whenever you have to remove the here dot you will get here cos angle. So we can write here BDL cos theta. But the theta value will be here because of L length of the element and the magnetic field both are in the same direction. So that's why we are taking here theta value is 0 degrees. Now you have to substitute replace of cos theta. You will get here line integral B dot dl is equals to. So line integral BDL cos 0 value is 1. Cos 0 value is 1. So now again we can write here B is a constant, we can write outside. The line integral into dl. What is the circumference of the circle? Because of C, it can be produced around the conductor, it can be produced some field. Okay, that field has in the form of circular shape. So here, what is the circumference of the circle means total length of the circle. What is the formula, sir? Means I am writing but line integral dl is equals to, what is that formula? We have to write here 2 pi r. So now we can write here b into line integral b dot dl is equals to b line integral dr means nothing but we can write here b into 2 pi r. But the b value is mu 0 I by 2 pi r. That's what we can write there. So mu 0 I by 2 pi r into 2 pi r. These 2 pi r cancel. So we'll get here line integral b dot dl is equals to mu naught into I. So hence we have proved that equation. This is the Amperes law. Everyone listen carefully. Okay, dosto. See here, this is the Amperes law statement. After the statement, this is the formula. Suppose if you have to remember here this formula, it is very easy to write the statement because of in that formula only is there. Integral of total intensity of the magnetic field around any closed loop is equals to mu naught times of the net current enclosed by the area of the bounded curve. This is the statement of this Amperes law. Okay, I hope you all are fine. Thank you, sir.